Chromatography is a method used to separate complex mixtures of compounds. The system consists of a mobile and stationary phase. The mobile phase can be a gas or liquid that carries a sample through the stationary phase. Compounds in the mixture can separate based on their affinities for the stationary phase and differences in the mobile phase. Thin layer chromatography, or TLC, uses glass plates coated with a stationary phase such as silica gel. The mobile phase will be solutions you will test in beakers. A less polar solvent is generally used for less polar compounds, and more polar solvents are used for more polar compounds. A mixture is spotted on the TLC plate, which is placed in a TLC chamber with a solvent or solvent mixture. Compounds move and separate based on polarity as the solvent travels up the plate. The mobile phase continues traveling until it reaches close to the top of the TLC plate. The plate is removed from the chamber and the solvent is allowed to evaporate. The RF value can be calculated by taking the distance between the spotting line to the distance traveled divided by the total distance traveled by the solvent. Polar compounds tend to stay close to the baseline, while nonpolar compounds can travel further. A nonpolar solvent system does not allow spots to move very far. A more polar solvent will result in nonpolar spots moving further. Place a piece of filter paper in a beaker to help saturate the TLC chamber. Add the solvent to the chamber and cover with a watch glass. Shown is a nonpolar and a polar solvent system in two separate beakers. You will experiment with solvents of varying polarity by making a mixture of the two. Set the chamber aside while you prepare the TLC plate. Take a small amount of sample and add it to about 1 ml of solvent to dissolve. Repeat with the other samples. Mix well. With a pencil, lightly draw a line on the TLC plate. Do not scrape the pencil line across the plate or the stationary phase will flake off. Draw hash marks to indicate where your spots will be. Have a small beaker ready with acetone to clean your TLC spotter. Dip the spotter into your sample solution. Lightly spot the plate, leaving a small spot. Allow the spot to dry before spotting the plate again. To clean the spotter, dip it in the beaker with acetone and dab it on a paper towel. Do this a few times. Then you can reuse your spotter for the next sample. Be careful not to make your spot too big, or they will bleed together. When you have finished spotting your plate, carefully place them in the TLC chamber. The solvent height in the chamber should be lower than the pencil line on the TLC plate. Lean the plate against the side of the chamber and cover with the watch glass. The solvent will slowly travel up the plate. You can see the spots moving up the plate as well, and they are separating now by polarity. When the solvent reaches about 1 centimeter from the top of the plate, remove the plate from the chamber and mark where the solvent reached. The plate on the left was in the non-polar solvent system, and some spots did not move off of the baseline, which you do not want. The plate on the right was in a polar solvent system. Although the spots moved off of the baseline, there is not good separation. This is also a polar solvent system. You will need to find a system with a mixture of the two solvents that will allow good separation and the spots moving off of the baseline. Circle the spots and calculate the RF values. For the spot on the far right, the RF value would be calculated by taking the distance traveled by the spot and dividing it by the distance traveled by the solvent, or about 2 centimeters divided by 3.5 centimeters. And this is how you can calculate RF values for each of your spots.